Is IP addressing. Today we are continuing the same thing. Okay, in terms of this IP addressing has been concerned, we are discussing about this IP version 4. Okay, this IP version 4 has been divided into two things. One is a classful IP addressing, and second one is classless IP addressing scheme. So in classful IP addressing scheme, we have 5 classes as I told: class A, class B, class C, class D, and class E. This IP version 4, the size of IP version 4 is, hello, I'm upload. Okay, we have 5 classes. So here, this IP version 4, the address size is a 32-bit addressing size. Here, this 32-bit has been divided into group of 8 bits called as octets. Okay, here each and every octet can have a value from 0 to 255. Each and every octet will have a value 0 to 255. Today, okay. Is it audible? Kannan? Am I audible to you? Yes. We are discussing about this IP version 4. Yeah, good morning, Narayan. So, in terms of IP version 4, here it is a 32-bit addressing. It has been divided into classful and classless schemes as we have discussed. Under this classful IP addressing scheme, there are 5 classes such as class A, class B, class C, class D, and class E. And we have a classless IP scheme. Currently, we are following classless IP scheme. Okay, here there are no such classes, which is represented in CADR, classless interdomain routing. Okay, it is the representation in classless IP addressing schemes. To given an IP address to which class it belongs to can be easily identified using this first byte. Okay, here if the first byte starts with 1 to 126, it is class A. 128 to 191, it is class B. 192 to 223, it is class C. 224 to 239, it is class D. 240 to 255, it is class E address. Similarly, if it starts with 0, it is class A, first 110 class B, 110 class C, 1110 class D, 1111 corresponds to class B. This is the machine understandable format. This corresponds to the human understandable format. Okay, here we also discussed about these masks. There are 2 types of mask. One is a default mask. The second type of mask is a subnet mask. The default mask is fixed. So for what reason we need to use the mask? Given IP address to find out the network path and host path. To find the network path and the host path, we are using. Can I know who is got connected now? HP, under the name HP. We have the network part and the host part. Okay, to find out this network and host part, we are using this mask. The default mask is fixed. Okay, for class A, it is 255.0.0.0. For class B, it is 255.255.0.0. For class C, it is 255.255.0. These are all the fixed things. These are all the fixed things. We have this class A, class B, and class C mask. Okay, we have so for Subnet mask, it is dynamic. Okay, the subnet mask is dynamic. It depends upon the number of networks. Okay, we will have a discussion on the subnet. It depends upon the number of networks and total number of subnet that we need to have. The number of computers in the subnet will define the subnet mask. Okay, it is dynamic. Okay, so here to given an IP address to find this, this is a fixer. Okay, this mask, this is a fixer. How you can identify, let me discuss now. Okay, so here, for example, this IP address 195.100.10.7. This is your IP address. First, what you need to find out to which class it belongs to. It belongs to class C. Therefore, you want to apply the class C's mask 255, 255, 2550. Okay, you want to apply the AND condition. Okay, if there is a 255, then the same value on the first row need to be replaced. If it is 0, it is 0. Therefore, this is the network part. Okay, the point 7 is the host part. This is the way by which we can identify the network part and the host part. Okay. So here we are going to discuss any address. For example, if it is 15.10.7.151. So here this is a class A. The mask is 255.0.0.0. Therefore, the network part is 15.0.0.0. Okay, this is the way by which you can identify network part and the host part. If there is a 255, the value on top of it will be replaced. If it is 0, it needs to be replaced. Here it is nothing but AND operation. You want to apply the AND operation. Okay. Okay. For each and every classes, okay, some bytes has been reserved for network and some bytes has been reserved for host. For class A, the first byte is for network, the remaining 3 bytes is for host. And for class B, the first 2 bytes is reserved for network and the remaining 2 bytes is reserved for host. And for class C, the first 3 bytes is reserved for network and last byte is reserved for host. And for class D, all the 4 bytes is reserved for network address. Okay, this is a fixed network part. So how many networks, class A networks, how many class B networks are there? If you take this count, here for class A, in this first byte, the first bit 0 is reserved for network. Remaining, therefore, we have 7 bits. Therefore, 2 to the power of 7 is equal to totally 128. So starting from 0 to 127, here excluding 0 and 127, we have addresses 1 to 126. There are around 126 class A networks throughout the world. Okay. So how many hosts in the each and every network? The host is 8 bit, 8 bit, and 8 bit. That is equivalent to 2 to the power of 24 minus 2, which is equivalent to 1 crore 67 lakhs 77,216. This much of a computer in each and every class A network. Okay. So this is the way by which you can find out how many computers are there in each and every class and how many total networks are there. So throughout the world, we have 126 class A networks. In each and every, for example, this 1.0.0.2 is a class A network. So in this network, how many computers that you can have? In a single IP address, we can have this much of computer. Roughly 1 crore 68 lakhs of computer is possible. Okay, just please make a note on this. Similarly, for class B here, 2 to the power of the remaining bits 24 minus 2. I will let you know what is minus 2. Okay, you wait a while. For class B, here we have the first 2 bytes is reserved for network, out of which in the first byte starts with 1 and 0. Therefore, we have left out with the remaining 6 bits, here 8 bits. Therefore, 2 to the power of 14 networks. Class B networks, 2 to the power of 14 networks. Okay. So here in each and every network, how many hosts? We have two parties reserved for host, 8 plus 8. Okay, 8 twos are 16, 2 to the power of 16 minus 2. 2 power 16, 65,536. Okay, minus 2. Therefore, 65,534. We have throughout the world this much of 2 to the power of 4, 16,000. Okay, it comes around 536, I think so. 16,536. Total class A B networks in the world. In each and every network, we have 65,534 computers. Please make a note. How? The last 2 bytes is reserved for host. The first 2 bytes is reserved for network. Out of which the first 2 bits is for identifying to which address it belongs to. Remaining we have 6 bits. Here we are having 8 bits. Then class C, the first 3 bytes is reserved for network, the last byte is reserved for host. Out of which 110 represents the network address, remaining we have 5 bits, 8 bit, 8 bit. Therefore, 2 to the power of 21 networks. Roughly it will be equivalent to 20 lakhs. Here only we have 8 bits for host, therefore 2 to the power of 8 minus 2, which is equivalent to 254. For each and every class C networks, we have 254 computers in the network. Okay, this is fixed with reference to a classful addressing scheme. Now we are following a classless addressing scheme. You please first make a note of this. These are all interview questions. Yeah. Hello? Class முடிக்கிறேன் class முடிச்சு Okay, here we have Class C, Class A, and Class B networks. Okay, so these are all the things associated with how many networks and how many hosts within the network. If you have doubt, any doubt here, please let me know. These are all fixed. The classless IP addressing scheme, we have allocation in form of 2 power n. Okay, where n is equal to 0, 1, 2, 3 up to. For example, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 like this. 2 power 2 means 4 IP address, 8 IP address, 16 IP address, 32 IP address like. So let me take this scenario. I need to have 10 IP addresses for my network. I am going to establish a local area network for which I am going to have 10 computers connect to the internet. Therefore, I need 10 IP addresses. If it is a classful scheme, which class that I need to go for? I need to go for class C. For class C, what is the maximum number of machines? 254 IP addresses is possible. Out of which I assign only 10, remaining 244 will be wasted if I go for a classful scheme. The same thing if it is a classless scheme. What I can go, I need a 10 IP address, I can go with the following 2 power 4. Therefore, 16 IP address will be allocated for me, out of which 10 I will use and remaining 6 alone will be wasted. Okay, this is the way. Imagine here if you follow classful scheme, 244 will be wasted. If it is classless, 6 alone will be wasted. This is the way by which if you go for classless IP addressing scheme, it will be very helpful in reducing the wastage. Am I making sense? We will now discuss about this classful scheme and laterly we follow the classless scheme for our purpose. Okay, these are all the types of addressing schemes associated with classful and classless. Now what we are going to do, we are going to discuss about the concept of subnetting. What do you mean by subnet? Dividing a network into smaller networks. Dividing a network into smaller networks has been termed as a subnetwork. Okay. So given a network, imagine you have a, what are the things you will be given a IP address. You want to find out, you will be given the total number of subnets that is needed. Then you will be given maximum number of computers in each subnet. So these are all the things you want to, these are all the given. What you need to find out? You need to find out three things. One is subnetwork mask, subnetwork address, range of IP address within that subnet. So these are all the three things that you need to find out. Please make a note. Okay, now we are going to discuss about these things. Okay, so these are all the given informations. Now we are going to discuss how to find out the subnet mask, then how to find out the subnet address for each and every subnet, and what are all the range of IP address that is permitted. This is very essential for our discussion. Okay, let me take first a class C address. So let me take this address 200.100.10.0. Okay, which is a class C IP address. I want 5 subnets. The company XYZ, a company XYZ is going to have branches across 5 locations. Therefore, they need 5 subnets. Okay, under each subnet, they need to have maximum of 30 computers under each subnet. Okay, the company XYZ has been given a Class C IP address. They want to establish branches across 5 locations, and therefore we need to have 5 subnets. Under each subnet, maximum 30 computers is need to be allocated. You want to find out two things. One is you want to find out this subnet mask. You want to find out the subnetwork address, and within that subnet, the range of IP address within the subnet. Range of IP address within that subnet. These are all the 3 things that we are in need of. Okay, first what you need to do, given the address, you want to find out to which class it belongs to, and you want to apply the mask. Think it is class C, you want to apply the mask, default mask. This is your mask. Okay, so you represent in forms of binary, all 8 ones, 8 ones, 8 ones, 0 0 0 0 4 0, 8 zeros. Okay, this is the equivalent. Here, this is your network part. If it is class B, this is your host part. Here you can't disturb your network. For dividing, what is a subnet? A given network has been divided into various smaller networks. This is called subnet. Here the given network has been divided into subnet 1, subnet 2, subnet 3, subnet 4 and subnet 5. We want to divide it into 5 subnets. Okay, this is our requirement. So this is the address that corresponds to this 255.255.255.0. Here what we are going to do, here what we want to compute this first subnet mask. How I can compute? Okay, I want to form 5 subnets. Therefore, I need to borrow some number from the host part. Let I take 1 here. If I take 1, that is 2 power 1, which is equivalent to, I can have 2 networks. If I take 2 here, 2 power 2, which is equivalent to 4. If I take 3 ones, okay, 2 power 3, which is equivalent to 8. I am in need of 5 subnet. Therefore, this satisfies my requirement. If I borrow 3 bits from my host, this is my host part. If I borrow 3 bits from my host part, I can able to establish 8 subnet. Okay, my requirement is 5 subnet. This satisfies. Therefore, what I need to do, so this is my network mask. I need to borrow 3 bits. Now this corresponds to 255. This 255, 255. Here you want to complete the value 111, 1, 2, 3, 4, 5 into 2 power 0 into 2 power 1, 2 power 2, 2 power 3, 2 power 4. Here into 2 power 5. Here into 2 power 6 into 2 power 7. 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128. Totally 8 plus 2 10 4. 8 plus 2 10 4. Here 224. Okay, the value is 224. Am I making sense what I am doing here? Sorry. Here I am finding out the subnet mask. How to find out the subnet mask? According to the number of subnets that we are needed, we need to borrow some bits from host. Since my requirement is 5 subnet, minimum I need to borrow 3 bits from host to form this 5 subnet. So once I identify how many number of bits I need to follow, this is my binary representation. The corresponding decimal representations I need to convert. So this is my subnet mask. My subnet mask is 255.255.255.224. First thing, okay. Now I have computed my subnet mask. If you have any doubt, please clarify your doubts. Okay, we have now created the subnet mask. First one, our subnet mask is 255.255.255.224. This is my subnet mask. Next, we need to compute the subnet address. Next, we need to compute the subnet address. Okay, how to compute the subnet address? From the mask value, only one value will be apart from 255. You want to minus this from 256. 256 minus 224, 232. You want to use this. Okay. Your first subnet address, what is your address? 200. What is your address? 200.10.10.0. Let me make it. This is class C. Okay. So here, how many subnets that we can have? If we borrow 3 bits, this is our mask 255.255.255.224. We can have 8 subnets. Okay, this is our subnet 1. Okay. The second subnet, you want to add this 32. Okay, every subnet will be 30. This is your second subnet. The third subnet, you want to add further 32. 200.10.10. Then you want to add further 32 plus 32, 96. Similarly, you can form a 10.96. You want to add 32 here. Okay, 98. Here 30 instance, 230, 226. Okay. 200.10.10.228 plus 32, 260. Okay, 292. These are all the ways by which we can form. This is the subnet 1, subnet 2, subnet 3. Okay, similarly you have 8 subnets. Actually, now you have the first subnet, subnet 1, subnet 2 address, subnet 3 address, subnet 4 address, subnet 5. Okay, sorry, one not 228, 128 plus 128, 160. Okay, 192, subnet 5, subnet 6, subnet 7, 192 plus 32, which is equivalent to 200.100.10.224. Okay, up to this we need to have. These are all 8 subnets. Is it clear? Now we need only 5 subnets. We can have 8 subnets. Now we have find out this subnet mask, and we have find out the subnet address for each and every subnet. Now what you need to do? You want to find out the range of IP address within that subnet. How many IP addresses are there possible within each and every subnet, that I need to find out. Okay. So for that, what I need to do here is, so the first subnet, for this first subnet, the first address starts with 200.10.1 followed with 31. 200.10.10.31. This is the range of IP address within subnet 1. Similarly, for second subnet, subnet 2, here it starts with 32. Okay, 200.10.10.33 up to the address is 200.10.10.63. Okay, so from 32 from 63. This is the range of IP address for subnet 2. Similarly, for subnet 3, it starts with 64. It ends up with 200.10.10.95. Similarly, here it ends up with 200.10.10.127. Okay, here it ends up with it starts with 128, end up with 200.10.10.159. That is one address minus the next starting address of next subnet. So this is the way by which we can identify the range of IP addresses that we need to assign within that particular subnet. Yes. Let us check how I can able to route the traffic within this. Okay, please make a note. That I okay, the range of IP address. Let me take one scenario and let me do this scenario. Let me take this subnet 4 and we do the scenario. If you have any doubt, please let me know. That's okay, in the classless scheme, let me take one example. Let me take a IP 192.100.10.1 slash. It will be represented in form of slash notation. For example, let me make it slash 26. So slash 26 means you want to find out the number of bits. Okay, out of this 4, 8 bit, 8 bit, 8 bit plus 2 bit. 8 threes are 24 plus 2 bits, which is equal to 26. Remaining how many bits are there here? We have 2 power 6. Therefore, we can have 2 to the power of 6 here. Okay, and for here 2 to the power of 2 here. I'm making sense? Here this 2 power 6. Total number of computers in this address is 232 minus 26, which is equal to 6. 2 power 6 equal to 2 power 5 32. We can have 64 computers in this network. Okay, we can have 64 computers in this particular scheme. If this is called CADR format, classless inter-domain routing. Instead of representing in form of here 255 255 2550 means it can be represented as 8 bit 8 bit 8 bit 24. It can be represented as a slash 24. If it is 255.255.0.0 means 8 bit and 8 bit, it can be represented as slash 16. Okay, slash 16. This is the way based upon the number of bits we can represent in CADR. So let me take this into 26 instance. So here how many computers that we can possible? 2 power 6, that is you want to minus from 32 minus 26, that is equal to 6. 2 power 6, 64 computers, that is possible. So I want to have 3 networks instance. The first network 192.100.10.12. So how many? I want 10 computers or I want 15 computers means so up to 15. Okay, and I want to start with 16 up to 30, like I want to specify here. Okay, 1 to 5, this is my first address, this is my 15. 16 to 30, 31 to 45, like I want to have. So here this corresponds to the first subnet with 15 computers, the second subnet and third subnet. This is the way by which I need to identify the range of IP address if it is represented in a classless IP addressing scheme. In classless addressing scheme, they will specify like this. Okay, given an IP and the CADR notation, I want 3 subnet. Each subnet should contain 15 computers like thing. Okay, this is the way by which we can split. Please make a note. While we are doing the practical with the VPC, virtual private cloud, you will have a clear identity, clear discussions. Okay, it will let you know more clarity. So with this, our discussion on this particular IP and subnetting is enough. I will let you know how the data transfer will take place now. Okay, let me take 2 scenarios. Okay, and how the transfer takes place, let me discuss. Here, this corresponds to one network. This is your source network. This corresponds to the target network. Imagine the target network has been divided into 5 subnets. According to this, let me divide into 5 subnets. Okay. So here we have computers assigned with the subnets. So this is our main network. Okay, this main network, this is your target network. Imagine the address is 200.100.10.0 is the network address. This corresponds to 150.100.10.0, and one computer here will be having address 150.100.10.5. And imagine this is your okay. How many subnets we have split it into? 8 subnets. The first subnet is 200.100.10.0. The second subnet is 200.100.10.32. Then the third subnet is 200.100.10.64. Okay. So all the computer within this will have the IP address. So here the computer here, when we imagine the address is 200.10.100.10.40 is the target computer. Is it clear what I am trying to convey? Here the source is in India, and we make the target is in USA. Let me take this scenario. First, the computer is connected with the switch, and we have a router. The router will connect the network. Okay, it will be interconnected in the internet with several routers. Okay, here too, this computer will be connected using a switch. Okay, so this is the scenario. Now a packet has been transmitted from the source network to the target. The source address will be 150.100.10.5. The target address will be 200.100.10.40. First, this packet will be transmitted to the switch. What switch will do? It will find out whether the source machine and target machine lies in the same network. How it can find out? It first takes this IP address. It applies the mask so that it can able to find out the network address. Here, being it is class B, the network address is 150.100.0.0. Here, being it is class C, the network address is 200.100.10.0. Now it will compare these two things. If both of them is in same network, if both of them is the same network, then switch will transfer the data without using the router. In this case, the source is to a network, the target is another network. What so switch doesn't know what to do. Therefore, it forwards the data to the router. Router will know how to reach the appropriate destination using some routing protocols. Therefore, the data will now reach us at the target, that is in US. Here only this router alone knows the target network has been divided into 5 subnetwork. Okay. Therefore, I want to specify under USA, you may have Los Angeles, you may have one network at California, you may have one network at Texas, you may have one network at Atlanta, you may have one network at New York. Now, according to the scenario, the computer is in Texas. So, once this reaches, this router, what it will do, it want to decide where the packet need to be forwarded, whether to Los Angeles, whether to California, whether to Texas. How it will apply the mask here. You know, we have a subnet mask here. Okay, this is your network address. We have computed the subnet mask. What is the subnet mask? 255.255.255.224. According to our requirement, we have computed the subnet mask. Okay, so it will apply on top of it. It will apply on top of it. Okay, now the packet reaches here, and here we have this subnet mask, and we have the subnet address. So it will take this IP address and apply the subnet mask to find out the subnet address. What is the use of this default mask? The default mask is used to identify a given IP address. To identify the network part, we use default mask. What is the use of the subnet mask? To identify a subnetwork part, we use the subnet mask. Let me compute this subnet address. Okay. Let I take this part so that we have completed the discussion. Okay, here let me take here. We have the following thing. We have the following subnet mask: 255.224. Okay, here the IP address is 200.100.10. What is the IP address? That is your 40. Okay, it is in subnet 3 in the subnet address. I want to find out of the given IP address. I want to find out which thing. I need to find out the subnet address. How to find this? Okay, I want to apply here 111.0.0.0.0.0. It is the equivalent. Okay, being it is 255 and operation, it will get the following. Okay, so 255 instance, we have 200. Okay, we have 200.100.10. Here only you want to apply 224. Now you want to compute for 40. The binary equivalent of 224 is 111.0.0.0. For 40 to 20 remaining 0, to 10 remaining 0, to 5 remaining 0, to 2s are 4 remaining 1, to 1s are 2, okay, remaining 0. Therefore 101.0.0.0. So to make it 8 bit, okay, now we have computed the binary value. To apply this 001.0.1.0.0.0. So what AND will do? If both of the thing is 1, then it will lead to 1. If 0 1 or 1 0 or 0 0, all are 0. Therefore here we have 0 0 0 1 0 0 0 1 1 1 0 0. Okay, this is the value. 2 power 0, 2 power 1, 2 power 2, 2 power 2 power 2 power 6. What is 2 power 6? Which is that 64. Therefore the value is 64. This is the subnetwork address. Therefore, what it will do after computing this, it will forward the packet to the subnetwork. This is the subnetwork address. So the packet will be reach the destination at the end. This is the way by which, by applying this subnet mask, this is our subnet mask. Is it clear for you? This is our subnet mask that we have computed. And this is the IP address, the target IP address. Now we have find out the subnet address. The subnet address is 200.100.10.64. This is the way by which your router will compute the subnet address based upon the following rules, and it will make the data reach the appropriate destination. Is it clear for you? Am I making sense what I am trying to convey?